Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. We are continuing with the derived quantities. In our previous lesson, we've seen area. We saw what area is. We saw the SI unit of area and other units and the types of area. Now we are going to look at volume. We shall see what volume is, the SI unit of volume, other units of volume, and the instruments used to measure volume, and the conversion of units of volume. So I request you to subscribe, comment, like, and share with colleagues. Otherwise, don't forget to hit the bell so that whenever we post a new video, you get notified. Thank you. Volume. Volume is defined as the amount of space occupied by an object, or the amount of space occupied by matter. The SI unit of volume is cubic meter. However, we have other units apart from the cubic meter. We have kilometer cubed, we have hectometer cubed, we have decameter cubed, we have the meter cubed, which is the SI unit, we have the decimeter cubed, we have centimeter cubed, we have millimeter cubed. These are all units of volume. We also have the liters, the milliliters, and so on. How do we convert? For instance, we can't convert kilogram cubed to meter cubed. We know that 1 kilometer equals to 1,000 meters. Then 1 kilometer cubed will be equivalent to 1,000 meter also cubed, meaning this gives us 1 kilometer times 1 kilometer times 1 kilometer equaling to 1,000 meters times 1,000 meters times 1,000 meters, hence giving us 1 times 1 times 1 is 1. Kilometer times kilometer times kilometer is kilometer cubed. So we get 1 kilometer cubed being equivalent to 1,000 times 1,000 times 1,000 is equal to 1 billion. Then meter times a meter times a meter, meter cubed, meaning that 1 kilometer cubed is equivalent to 1 billion meters cubed. We can also convert 1 meter cubed to centimeter cubed. We know that 1 meter is equivalent to 100 centimeters. Hence, 1 meter cubed will be equal to 100 centimeters cubed. Therefore, this is 1 meter times 1 meter times 1 meter equaling to 100 centimeters times 100 centimeters times 100 centimeters. That giving us 1 meter cubed equaling to 1 million centimeters cubed. So that is And then if we divide by 1 million, that leaves us with the 1 over 1 million cubic meter being equivalent to 1 centimeter cubed. That is, if we are converting from centimeter cubed to meter cubed. So that is how we convert units of volume. After looking at the units of volume and how we convert them, we can now look at the instruments used in measuring volume. Instruments for measuring volume, we can use a measuring cylinder. That one is the simplest because it is already calibrated. We can use a burette. We can use a pipette. We can use a volumetric flask. We can use a calibrated beaker. These are some of the instruments that we use in measuring the volume of substances. Now, we have volume of some regular objects like a cylinder, sphere, Satular Cone, cuboid. Let us look at the volume of some of these regular shaped objects. If we have a cylinder, we have a cylindrical tanker, then its volume is given by, because if you look at a cylindrical tanker, it has a base area. So it is base area, but the base is in the form of a circle. Therefore, the base area is pi r squared, where r is the radius of the circular base, times the height. So it is pi r squared, which is the base area, times the height. That is volume of a cylinder or a cylindrical object. When we look at a circular cone, a circular cone is a cone whose base is circular. Still, the volume is given by a third pi r squared times the height. So this is a third the base area times the height. That is for a circular cone. Then a sphere. A sphere is similar to a circle. The only difference is that a circle has uniform radius, whereas a sphere has two different radii. So the volume of a sphere is given by 4 over 3 pi r cubed. That is the volume of a sphere. We look at a cuboid. This is our cuboid, and its volume is given by length. If this is the length, by the way, this was the radius, So it is given by length times width times height. For a tube, since it has all sides equal, the volume will be length times length times length, which is length cubed. Then, for the good mathematicians, for those who are in higher levels, HS and so on, how do we get volume? Volume is obtained when you integrate area. Integrate area to get volume. Then area is given by differentiating volume. Hope we are together on that for those who are in HSC. So after looking at volume of different regular objects, we can now look at how we get volume of certain substances. For instance, volume of a liquid. Volume of a liquid is obtained by pouring the liquid in a dry, clean measuring cylinder. And where the liquid level stops, note the mark at that point, and that becomes the volume of the liquid. Then we have irregular objects like stones, those that have no shape. The volume of an irregular object is obtained by displacement method or the Satular Cone method, whereby for displacement you carefully immerse the stone in water in a measuring cylinder whose initial water level has been noted. So on immersing the stone in the water level rises, and note the new water level. Then the difference between the initial water level and the new gives you the volume of the stone. However, we have irregular objects that float. For instance, how do we get the volume of a piece of dry wood? Because you know that dry wood does not sink. So it will be hard for us to use displacement method for floating objects. For a floating object, you will tie what we call a sinker on such an object. For instance, if you want to know the volume of a pencil floats on water, but tie a sinker on it. It can be a small piece of metal, it can be a small stone. So you get the volume, you first get the initial volume of the water, then you immerse the sinker alone, you get the new volume, then subtract to get the volume of the sinker, then tie the sinker on the floating body and immerse them, get the new reading, then you get the reading of the sinker minus the reading of the sinker plus the floating body. That is how we get the volume of floating object. Otherwise, thank you for having us. Please subscribe, hit the notification button so that whenever we post videos you get notified and we learn together. Thank you.